In this video, I want to talk about some of the additional aspects of Mathcad. In the 8th edition of the AASHTO LRFD bridge specs, there's a chart that's shown here in section 10.6.3.1.2b, which talks about consideration for punching shear. And so if you were to look at the region in this graph over here to the left, which refers to the relative density of sand versus the relative depth, you'll see there's three different areas. If it plots in the punching shear area, you have to make some adjustments to the bearing capacity. So this chart is in AASHTO. Actually, the little chart over here is the one that's actually in AASHTO. But I went over to the actual original paper, which was written by Alexander Vesic in 1973. It's in the Journal of the Soil Mechanics and Foundation Division of the ASC Journals. Volume 99, SM1, pages 45 through 73. Vesic gives this chart, but he doesn't give a function that explains how to graph this thing independently. So what I wanted to do is that I wanted to digitize this in Mathcad and automate the system so that you could check for punching, local, or general shear without having to actually plot this thing manually and then make a decision about which way to go. So the great thing about Mathcad is that it allows you to automate almost anything, but sometimes you have to digitize graphs and charts. And so I wanted to show you how to do this here. So here's the chart that I got from the Vesic paper. Here's the chart on the right that is actually in the AASHTO 8th edition of the Bridge Design Manual. And then here's the text that talks about if you have punching shear, in other words, if it plots to the left of the line here in the middle of the chart, then you have to alter phi and c to account for that. So what I did was I found the paper, which I have in my library that Vesic wrote. I made a copy of it. I scanned it at a really high resolution, and now I'm going to show you how to digitize something, and I'm going to use AutoCAD. I used to use MicroStation, but in the last few years I've kind of gotten more used to AutoCAD, so I'm going to show you how to do this in AutoCAD. So I opened up AutoCAD, and one of the things that you need to make sure is that in this little button over here in the lower right, you want to make sure that it's set to decimal. So I've got it set to decimal, and then I'm going to type in XREF, and I'm going to pull in a reference file. So type in XREF, this little dialog box comes up. The little button to the left says attach image. I'm going to attach an image, and I'm going to attach this particular image right here. And I don't know what the scale of this thing is coming in, so I'm just going to put it into AutoCAD, and then I'll adjust the scale later. So let me move this box out of the way. Okay, and so now it is going to bring the image in, and a couple things I want to do. Let me just have a place to put it. Okay, and now you can see that's pretty good. That's pretty good. So let me move it around just a little bit. Well, actually, I'd have to go back in. Let me just leave it like it is for right now. All right, so I'm going to go in, and I'm going to draw some lines here. Let me change the color so that it's easy to see. So I'm going to draw a line. I'm going to zoom in, and I'm going to get dead center of the black area. And then in AutoCAD, if you hit the F8 button, that makes everything horizontal or vertical, depending on which direction you're drawing. Okay, so I've got a horizontal reference line. And now I can check, and I can see that this thing is not rotated just like it should be. All right, it starts out good, but over here on the right, you can see that it's rotated a little funky. So I need to fix that. So let me show you how to do that. So I'm going to draw another line and just find out how much it's off. So now I don't want to draw a horizontal line. I want to draw one at some angle. So I'm going to hit the FH key, and I zoom in with my mouse. And that right there, let me zoom in a little more. That right there looks pretty good. It looks pretty good. So now I need to figure out, well, how much do I need to rotate this? So I'm going to see if I can't measure how far up that is. So let me go to Properties, and you can see the angle is at 0, but that's not really it's not really 0. So I don't have my precision set just right. So instead of going back in and monkeying with my precision values in the thing, I can just use this little calculator here, and I'm going to hit this button. It's going to help me calculate the angle of a line defined by 2 points. So I hit that, and now it's asking me to find the 2 points. So here's the first point, and I'll toggle over. And there's the second point. Okay, and so what AutoCAD is telling me is that it's 0.24312351, either degrees or radians, I forget which. I think it's degrees, tilted in the wrong direction. So I'm going to copy this, and then I'm going to close that. Copy is Control C, and paste is Control V in just about any Windows product. Yeah. So I'm going to select this. I'm going to rotate it. Let me close this. And then I'm going to use this as my point of rotation. All right, so now I need to rotate it in this direction, so that would be the negative, and then I'm going to hit Control V. All right, and let's see how that did. That looks pretty good right there. So that's pretty much dead center of the graph. So now I've got the thing rotated like I want it to, but I'm pretty sure that the scale is not right. So let me move this line back over dead center. Whoops, didn't move. Let me do that again. There we go. All right, so let me measure the length of that line. And there's a nice little routine here in AutoCAD. If I type in list, L-I-S-T, it gives me some information about this line. So it says, okay, here's my starting points. My length is 5.5522. So let me write that down. 5.5522. All right, and so I need it to be 1. So I'm going to have to scale this thing down. But let's think about this before I just start going and scaling it in certain things. I'm going to have to scale it probably in 2 directions. It's probably pretty close here. Let me draw another line and hit my F8, so that takes it down vertically. And you can see I'm just a little bit off here, which means that the image was skewed just a little bit. So there's going to be some error here. But let me see how long that particular line is. Let's see if I can select it. There we go. And we'll type in list. And it's 5.5226. All right, so I'm going to have to scale this in 2 directions, and that can be kind of frustrating in AutoCAD. The way to do that is turn this into a block. So I do that and I type block, and it will allow me to scale this in the X, Y, and Z direction. So I'm going to call this VESIC. And I'm going to hit OK. And I want to make sure that that Scale Uniformly button is not clicked. So I hit OK. All right, so now it's going to let me scale this thing in a couple of different directions. So let me go back to list. And again, it's 5.5522. And I've got to get that to 1. So if I type in 5.5522 in my calculator and hit the inverse key, that gives me 0.1801. Testing. So when 1, 2, 3, test. Rotate this thing, or I'm sorry, when I scale this thing, I'm going to select it, and then I'm going to put my mouse somewhere on the screen, and I'm going to right click, and I'm going to go to Properties. And when I go to Properties, you see that under Geometry, I've got 3 different scales here. So I've got an X, Y, and Z. So I know that I need to change the X scale to 0.1801. All right. And then I need to change the Y scale as well. So in the Y scale, the length that I measured was 5.5226. So 5.5226, I'm going to divide that by 5. So that gives me 1.1 something. So I'm going to take the inverse of that. And so that gives me 0.9054. So if I were to fix my calculator so that I had more digits, then it would be a little bit more accurate. But this is going to get me really close. So I'm 0.9054. Okay. Let me close this screen. Let me measure this. One and the other is basically 0.1. And then from here to the other end is basically 0.5. So tens, 100,000. So I'm a little bit off, but it's pretty close given the scale. You know, thousandths of an inch is pretty close. So now that I've got the thing set to scale, there's one last thing that I need to do to make it easy on me. And the easiest thing to do is to reset the coordinate system of AutoCAD so that if I were to put a polyline in, then I can just pick the points off of that thing, and AutoCAD will tell me what the Cartesian coordinates of this is. So I'm going to type in UCS, hit enter, and then I'm going to pick this point at the intersection of the 0, 0. Wants me to accept, yes. And so now it's hard to see, but the XY axis is now set at the origin of this graph. So when I draw the polyfit line, a polyline, let me go ahead and draw it. I'm going to start up here, make sure that I have my F8 key hit so that it's now free to roam. And I'm just going to add some points here. And the closer I get to the part that actually starts the curve, that's where you need to put more points so that you can actually more accurately pick up the curve. I'm just holding down the little mouse wheel and clicking and dragging, and let me get right there. Right click and hit enter. Okay, so now that I've got this, let me select that line. All right, so now that I've got it selected, you can see all those dots. Those show where I actually clicked my mouse and made points. If I type in list, L-I-S-T, and hit enter, it gives me all those points right there. All right, so if I hit enter again, go back to it, you can see now I've got all the points in here, so I can copy those, hit Control C. In almost any Microsoft product, Control C and Control V are your copy and your paste. button. So I've got that in. Let me go back to Mathcad. And now I need to get this data into Mathcad somehow. So what I could do is that I could open up a spreadsheet and I could copy those in and then import them into Mathcad through the read Excel function. I'm going to do it a little bit different this time. I'm going to open an area, hit my enter key a few times, and now I'm going to add, remember in an area I can close it and it disappears. So I'm going to go into input output. I'm going to insert an Excel component. It's going to take a second. My computer's a little slow today. I think I got too much open. So there it is. So now I've got a place that I can input stuff and a place that I can output stuff, but I've got these rows and columns here. So if I double click this with my left mouse button, it opens up a spreadsheet, and now I can hit Control V and it automatically pastes all that information in. So when I close this, there's all the information. Now, unfortunately, in this particular format, it's just text. It doesn't recognize it as numbers. So I've got to convert this, go to the data heading, hit text to columns. I'm going to do a delimited width. I'm going to click all my delimiters here and then hit finish. Okay, and so this transforms everything to where it should go. So I'm just going to delete this column first, shift everything left. All right, and now I just need to delete the columns and keep the data. Delete, and then I can delete these rows. Okay, delete that and this. So I've deleted all the text, and what I have now is the actual points from the digitization. So let me go back to AutoCAD and let me digitize this next line. I'm going to use the same polyline. And again, I don't need the points very close on the straight line portion of it. It's just where it starts to curve that you really need those points so that you can accurately pick up and do a curve fit to pick the functions up. You see it's still pretty straight, but as I get closer, then I start getting where I need points a little bit closer together. So those of you that need to digitize something but don't have AutoCAD or don't know how to use it that well, I'm not a very good user. I've putzed with it for years now, but I'm not a power user. All right, you can show them this video, they can do it for you. So now I've got that line drawn. Looks like I've got some funkiness going here. Let me move that point right there. We go. You can adjust these points once you get them drawn so that they're a little bit closer. Okay. That's kind of wonky right there. Let's see. There is a little button that I can add a vertex. Yeah. No, there was the button right there. So you can add a vertex, and then that gives you some room to fix all this stuff. All right. So once you get this just like you wanted, then you can click and drag, type in list, hit enter a few times, go back and get the history of it. Looks like I got all the points. There we go. So now I can copy and paste those. So copy, go back to Mathcad, double click the Excel spreadsheet, and I can paste all that stuff. Now let me get it in let me move it around just like I did before. Delete these, move them left. All right, so now I can get rid of all this, and I can get rid of that. I can get rid of D, and I delete that, and that moves them up. Yes. Okay, so looks like I've got the points that I need. Let me close this, and now everything's back into Excel or Mathcad. It's into the Excel component of Mathcad. So now I need to get this stuff out. So I've really got 4 sets of data here that I need to get out. The first and third columns are my X values, and my second and fourth column are my Y values. So the way we get this out is that I'm going to give this column, this first column, the name X general shear, and I'm going to set that equal to this variable. So we use the keyword Excel, and then I'm going to hit the key on my keyboard next to the P. So on a QWERTY keyboard, it goes IOP, and then the next key is these left braces. So I hit that, and it drops the cursor down, and then I'm going to type in quotation marks, SHEET, 1 exclamation point, A1 colon A15. All right, so when I go outside of my Excel and I type in XGS and then hit the equal key, then that gives me those values that I've typed in here. Okay. And I can change the formatting if I want to. So let me close that. So I'm going to do the same thing for the rest of the data. Matter of fact, so I'm going to call Y sub GS, set that equal to Excel, little drop down button, sheet 1 prime, B1 colon B15. All right, and so now I need to do the same thing for the other one. So I'm going to call this next one local shear, EXEL, the little brace button, sheet 1 exclamation point C1 through C20. Let's see how many I got. 17. So it's C17 instead of C20. All right, and then I do the same thing here. YLS equals brace quotation sheet 1 exclamation point D1 colon D17. Okay, so now I've got all my data out. So I got the data in the little Excel component, and now I've got it back out in the Mathcad. And if I want to, I can close all that and hide it. for presentation purposes if I don't necessarily want somebody to see this. So let me show you something else you can do. The great thing about this particular setup is that you can do anything in Excel that you're normally used to just from inside Mathcad. So I'm going to insert a chart. Let's just graph this stuff and see how it looks. All right, so I'm going to select data. I'm going to add. This is going to be my general shear. And I'm going to pick these data points for X, pick these data points for Y. Okay. Now I'm going to add another one, call this local shear. Here's my X data points. Here's my Y data points. And I'm good. Now if I want to, we know that I can add a trend line in Excel. So blow this up a little bit. Let's see. Obviously it's not linear, not logarithmic. Polynomial looks pretty good. It's not allowing me to use a power function. Let me increase the number here. Okay, that looks pretty good. And let me set the display and the equation onto my graph there. And then let me do the same thing for the other one. I'm going to add a trend line. I suspect it'll have the same properties. I need to bump up the number of... So at some point, yeah, I think Excel only lets you go to 6. All right, at some point you can have too many. So let me display the equation and put the R squared value on there. Close this. And now when I close this file, you can see that, you know, it kind of shows up. Let me make this a little bigger. Let me go back into Excel. And if I wanted to, move this over. See how that looks. Yeah, it looks pretty good. So what I've got here is that I've got the equations in Excel, both for this curve and for this curve as well, that I can use to compare how Mathcad does that. So let me close it up. So I'm going to stop this video now. When I come back in the next part, we'll show you how to actually do some curve fitting in Mathcad.